All right, guys, so we're going to add some new stuff to our notebook. This is going to be on page 46 and 47, and we are going to talk about linear patterns. So math is all about patterns, looking at how things behave over and over and over again, and then trying to make a guess about what they're doing. So we're going to be taking a look at what a linear pattern looks like today. And then we're going to take a look at nonlinear patterns and how we can tell the difference between those two things. Okay? And we need to look at them in different ways because so far we've taken a look at graphs, tables, and not so much equations, but we need to start a little bit with equations. Okay? So if I take a look on 46, we don't have anything right now. And then 47 here, at the top, I'm going to write linear patterns. I'm going to leave a little space. We might fill that in as we go. But what we want to take a look at is how is this thing growing, like the ghosts. How are they growing? So you can notice like how the ghosts are being added. That's great, like added to the picture. But more importantly, we want to talk about how many ghosts are there. So here, there are 2 ghosts, and then I have 1, 2, 3, 4, 5 ghosts, and then I have 1, 2, 3, 4, 5, 6, 7, 8 ghosts. And so I need to think about, like, how is this growing? It went from 2 to 5 to 8 because I want to think about how many ghosts will be in the next step. So if you notice, when I go from 2 to 5, I went up 3. It's like I added 3. When I go from 5 to 8, I added 3. And so it seems like the pattern is growing by adding 3 ghosts each time. And so that must mean that in the next step, there should be 11 ghosts. And then after that, I would think 14. And then after that, 17. It's just good to have a lot of numbers, okay? So we can represent this pattern in 3 different ways. We can make a table. So in our table on the X side, we're going to talk about the step. And over here, we're going to talk about how many ghosts. So on step 1, there are 2 ghosts. In step 2, there are 5 ghosts. In step 3, I had 8 ghosts, which helped me to see the pattern that in step 4, I should have 11 ghosts, and in step 5, I should have 14 and all of that. Now, I can also write a graph. So I can plot this as a graph if I think about my X and Y axis. And I did skip right an equation. I'll come back to it, I promise. So if I plot this point, I would go over 1 up 2, over 2 up 5, over 3 up 8, 1, 2, 3, 4, 5, 6, 7, 8, and then over 4, 1, 2, 3, up 11. So, some things to notice. First of all, if I think about how the table is growing, each time I go up a step, I add 3. Also, something to notice is that when I look at a graph, this graph right here, I am able to perfectly connect all these points with a line. That's why we call this a linear pattern. Linear is another word for line. So linear patterns represent lines. So I can see that it's a line in my graph because it's a straight, like I can draw a straight line through it. I'll also know from a table that it's linear if I'm adding the same thing every time, or if I subtract the same thing every time. And so the hardest part is to really write an equation. If I'm adding something over and over and over again, then I don't want to keep adding. We want to do the shortcut for that, which is multiplication. So since I'm adding 3 over and over and over again, that means I really want to do 3 times something, like whatever the step is. So if I think about it, if I do 3 times the step right now, I don't think it works out. 3 times 1 is 3. It's not 2. And 3 times 2 is 6. It's not 5. But each of those, if I took one off, I would have it. So if I subtract 1, I think it'll work now. So it's a little bit of trial and error. But if I do 1 times 3, that's 3, and then subtract 1, and I have 2 ghosts. If I do 3 times 2, that's 6, subtract 1, I get my number of ghosts. I think it'll work again as well. If I do 3 times 3, that's 9, minus 1 is 8 ghosts. So this is my equation. And using proper function notation, I would say that f of x equals 3x minus 1. All right, let's try another. Okay, if we take a look at another example here, we're going to take a look at how the trees are growing. So here I have 3 trees. Then I have 5 trees. Then I have, what? 1, 2, 3, 4, 5, 6, 7 trees. Jeez, it's just counting, Missouri. Come on. Oh, yeah. So if I take a look at how the pattern is growing, I started with 3, and then I'm at 5, and then I'm at 2. Nope, I spoiled the surprise. Then I'm at 7. I think I'm going up by 2 each time. So add 2 trees. So that must mean that there will be 9 trees in the next step, and then 11, and then 13, and da-da-da-da-da. So again, it's good to just follow the pattern out a few times. So if I make a table just like I did in the last one, over here we're going to have the step, and here we're going to have trees. So in the first step, I had 3 trees. In the second step, I had 5 trees. In the third step, I had 7 trees. And so I can even see my pattern right here, up by 2, up by 2. And so when I go to the next, we should be at 9, and then 11. So again, when I'm looking at a table, I can tell that it's linear if I'm adding or subtracting the same thing every time. Now, when we wrote our equation, that number did show up because whatever number I was adding over and over again, I ended up multiplying it to x. So same idea here. If I think about writing my equation right now, if I do f of x equals, then I think I should do 2x because I'm adding 2 each time. So if we see if that works, like if I plug in the step, if I do 1 times 2, that's 2, so not the right amount of trees. It's 1 more. Maybe I need to add 1. If I try 2, 2 times 2 is 4, but I need 5. All right, so I think I got to add 1. And if I try one more time, I think this makes sense. If I do 2 times 3, that's 6, plus 1 will get me the 7 trees that I need. So I can also then graph this, and I can really just graph it by plotting the points that I have. So 1, 3, then 2, 5, then 3, 7. And I wonder if you can also see the 2 kind of showing up here. And 4, 9. And again, I can tell that my graph is linear because I can draw a straight line through all those points. So it's important that we understand a couple of things. To tell that something is linear from the table, I need to make sure that I'm adding or subtracting the same amount every time. So add or subtract same number each time. Now we saw that here because we were adding 2 every time. We see this here because we're adding 3 every time. As long as we are adding or subtracting the same number every time, it's linear. From the equation, I can tell that it's linear. Now this one's actually trickier. I'll come back to that one. The graph's easy if you can draw a straight line through it. So if you can draw a straight line through it, through all points, then it's linear line. Now the equation, like I said, guys, is a little bit trickier to explain, but essentially what has to happen is you have to have a number multiplied by x, and x can't have any sort of exponent or any sort of denominator. So to tell from the equation that it's linear, there is a number multiplied to x. X has no power, so no exponent, and x is not in the denominator. And that's true for these. When I say that x is not in the denominator, that doesn't mean that there couldn't be a number in the denominator. Like you could have x over 2, and that would be fine because x isn't in the denominator. But these ones have a number multiplied to it. Even if that number was 1, so I didn't really see it, that would be fine. X does not have a power, so it doesn't have an exponent. And x is not in the denominator. So I know that was only 2 quick examples. Oh, I know what I'm going to do now. Your homework. So let me pull this up. So your homework, that is not what I wanted to click. This right here. We want to do this first one together. I'm not in the right hour. There we go. So our homework has to do with this linear pattern stuff in Google Slides. So it's the same idea. So this one here, if we take a look, we want to answer the question, how is the pattern growing? So I can see that there are 1, 2, 3, 4, 5, 6 snowflakes. And then there are, let's see, 1, 2, 3, 4, 5, 6, 7, 9. So we had 6 and then 9. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. So from 6, seems like I'm adding 3 each time. So in here, I would type, the pattern is growing, add 3 each time. How many snowflakes will then be in the next step? Well, that last step had 12. So if I add 3 again, there would be 15. And if you want to keep going, like 18, 21, something like that. So that means my equation, well, maybe I'm going to come back to my equation. Let's edit our table. So if I type in the number of steps, on the first step, I had 6 snowflakes. On the second step, I had 9. On the third step, I had 12. And then on the fourth step, I guessed that there would be 15. And so then on the fifth step, there would be 18. Now, it's a little bit trickier to do our graph, but what you can do is on this little button right here, we can add a line. So if I click on that, I can do the one with an arrow. That's fine because I assume it could keep going. And so this first one, I want to start at 1, 6. 2, 3, 4, 5, 6. And then the next one, I'm going to go over to 2, but I need to go up to 9. So I'm already at a height of 6. So I'm going to go 7, 8, 9. And I don't know if I'm going to be able to get to the next one, but I'd be over at 3 and then up to 12. So I think that's going to be kind of off the grid here. But I can see that it is a line. We can change the color and make that cute if we want. Like maybe I'll make it blue like the snowflakes. So cute. Look at that. And so then when I want to think about the equation now, because we're adding 3 every time, we would write our f of x equals 3x, because we're timesing by 3, or we're adding 3 over and over, which means times by 3. And then I just got to make sure that it makes sense. So if I plug in number 1, like the first step, 3 times 1 is 3, which isn't 6. Like I need 3 more. Maybe I got to do plus 3. So let's try that on the next one. If I go to the next one, I plug in a 2 right there. 3 times 2 is 6, plus 3 is 9. Oh, I'm going to check it one more time. For the last one, or the one that we had, 3 times 3 is 9, plus 3 is 12. Hey, all right, so there's your equation. So if you watch the video, you should already have number 1 done on your homework. And yeah, we'll talk more about it tomorrow. Bye, guys.